Probability Part 1. Simple probability. Suppose you did an experiment of tossing a fair coin twice. One outcome of this experiment could be you get a head on the first toss and a tail on the second toss. Another possible outcome is you get a tail on the first toss, a tail on the second toss. The set S of all possible outcomes is called the sample space. And S equals, in this case, is tail, 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 head, head, tail, head, head. That's everything that can happen. Okay. An event is a collection of one or more of these outcomes. The probability of an event A occurring, we'll call it event A, is written P with A stuck in it, or P of A, is the total number of ways an event A can happen divided by the total number of equally likely outcomes, or the cardinality of the sample space. So here it is. Number of ways A can happen over the total number of outcomes, and these have to be equally likely. Probability can be a fraction, a decimal, or a percent. However, the probability of event A occurring must be as below. It has to be greater than or equal to 0 and less than or equal to 1. A probability of A equaling 1 means that A will certainly happen, means it's a certainty. The probability of A equaling 0 means that A is impossible, it won't happen. Here's our basic problem that we're going to use. Okay. A jar contains 5 balls that are numbered 1 to 5. Also, 2 of the balls are yellow and the other 3 are red. They are numbered and colored as shown below. So we have these 5 balls, and what we're going to do is we're going to randomly select balls out of that jar. Okay. If we randomly select, find the probability of randomly selecting a red ball. If we just close our eyes and reach in and grab a ball, what's the probability it's red? Well, there are 5 balls, so the size of our sample space is 5. And then 3 of them are red, so we put the 3 on top. And the probability that we're going to get a red ball is 3 over 5, okay, or 0.6. And the second problem, find the probability of randomly selecting an even numbered ball. Well, again, we have 5 balls in the sample space, and how many of them are even? There's a 2 and a 4. So there are 2 possibilities for the drawing an even numbered ball. So the probability of drawing an even number ball is 2/5 or 0.4. In the second part, we'll begin looking at other kinds of more complex, really, kinds of probabilities. And we'll first start with mutually exclusive events, defining that.